So, good morning to all. So, we will continue the problem. In fact, in this problem what we have done so far, we have done the ray diagram aspect, right, for each speed using a tire formula, find out the tire radius. With that we try to find out the ratio, gear ratio, file rev ratio, overall ratio. From the overall ratio to we moved vehicle speed, right. From the vehicle speed we have completed the this ray diagram. Okay. So, general operation we discussed, transmission types also we have discussed, ray diagram also we have completed, and today's lecture we are going to focus about a kinematic diagram and also number of teeth in each gear calculation. Those are the things we are going to discuss in today's lecture. In fact, just wanted to give recap the basic transmission types, right, single stage, double stage, okay, and multi-stage. If you look at a single stage, the input is one shaft. This is the input is one shaft. Then you will have output the next shaft. That's a two arrangement. Only two shafts are involved. Whereas if it's two stage, this is your input shaft. From there, the transmission goes to your output shaft, or you can say lay shaft. Intermediate shaft is called lay shaft, right. From there the transmission goes to through the output shaft. So, this is called two stage gearbox. In fact, this is the one we are going to use extensively in automobile transmission. The configuration looks similar to your riveted gear train. Your input will come in this direction, then okay, then you will have a lay shaft. From here to lay shaft, then you will have an output shaft. So, the input and output are in the straight line, so that it will make more compact, right. So, this is the riveted gear train arrangement. The same riveted gear arrangement we do it or we imply in the manual transmission as a two stage, and this is a three stage. In the three stage, what happen? You will have one input shaft, right. You will get a two output shafts. This is the one, you can see that this is the one output, another one, this is another output. So, this kind of arrangement is a special arrangement. Okay. Anything beyond the three shafts or different directions normally called as a multi-stage. And it's interestingly, this is the real manual transmission gearbox. You could see here, this is taken from it is displayed in our machine design building in the at the entrance. You could see that. Whenever you use it, you can go and see this gearbox. Look at where is the input starts come. This is your inputs. You can see that this is the input, and this will have reduction straight away, and this is your lay shaft. From the lay shaft, transmission goes to the output shaft. This is your output shaft. So, this is the very arrangement. Okay, this is your lay shaft, and please pay attention closely, right. This is sliding mesh again. This is sliding mesh, spur gear. If you look at the teeth arrangement, which one is the first gear? Which second, third and fourth? The larger the one is the first gear, right. You could see this is the first gear, second gear, and this is your third gear, and this one more is joint is given, that is usually used for fourth gear. Okay, that's information. And also observe, there is one which you have to observe. Okay, we are not showing any the reverse gear, it is not visible here. Okay, that's we will ignore it. And what is the other information you get from this figure? Look at the first gear, second gear, third and fourth. What is that you are observing? What is that you are observing? The size is changing, right. I am not talking about the gear size. I am talking about your face width. Can you see that? Can you observe it? The face width is larger. Okay. Then the next you will understand another phase width. Then as you move on to the higher speed, the phase width is keep reducing. Okay. Remember the first point, our gearbox is to be as small as possible. It should be optimized and the weight should be also as low as possible, right? Okay. We could have straight away same phase width, that is fine, but as shifting the gear from first to second, what happened to your torque requirement? Higher the torque, lower the speed. So you have that success will be more. The success will be more. Okay. Straight away we can have fix this phase width to the all the gears. As you move on to the higher speed, your torque reduce. When you torque reduce, what happens? The stresses will be reduced. So in that case, do we need the same phase width? No need. Okay. So you can reduce it. So by doing that, you are making the gear weight even further down. Right. That's you have to be considered during the design aspects. And as I said, from the engine straight away we reduce the speed reduction. You can see that. From there we vary that. And interestingly, this is taken from Maruti Suzuki. They have same arrangement, slightly different. Okay. You will see that this is the first, second, and this is first arrangement from the engine, right? Okay, and the third, fourth, and fifth. At the end, this is output shaft. This is your output shaft. They make reduction. Either do it at the beginning, if the arrangement is possible, or else you can do it at the end also. Okay, which one is better? At the beginning is better, or at the end is better? Beginning is better, because by doing that I don't need to have another shaft. It will make the even more bigger size. It will make even more bigger size. If you do it at the beginning itself, my size will even more compact. Okay. So now we will do the kinematic diagram. Okay. So far the ratios are given. We have not considered what is the gear type, but in the problem clearly mentioned is constant mesh gearbox. Okay. This is a constant mesh gearbox. Yeah. So when you say constant mesh gearbox, you can choose. You have freedom to choose whether you want to have a spur gear or you can choose the helical gear. Both you can use it. Okay. So it's a constant type. The mesh type is constant mesh gearbox, GB. So gear type we have not considered so far. We can assume it now itself. We can assume as a spur. You can have both helical and spur. We will assume as a spur. Okay. Then when you say spur, the profile would be full depth involute profile. Full depth involute. That is the profile, right? Usually we use involute profile. What about pressure angle? Standard pressure angle you will get pressure angle psi usually 20, right? You can have 20. So it's not given, but we choose as a 20. Okay, that's the one thing. So this is the information we have taken at the moment. Spur, full depth involute, and the pressure angle 20. That's okay. The another information I would like to emphasize about these things. Okay, this is the constant mesh is fine. How are we going to arrange the gearbox? Can we arrange the speed from right to left or left to right? Either way is fine. Either way fine. You can do either way. But after doing that, you have to check the dynamics of the rotating masses. That is very critical. So the first you would expect the shaft from clutch input, right? The clutch input is coming from the clutch. Yeah. Is there an information the gear ratio saying 1? Did you see anything 1? No, right? So there is no, then there is no connection input and output as a one joint is there. Okay. So I will have a one gear. Right. This is my input shaft coming from the input shaft. from here it reduced, okay, it will reduce to at least by mostly half the size will be reduced. So yeah, I'm just, this is my lathe shaft. So what is, this is the lathe shaft, right, and this is the shaft, right, output shaft. Okay. So how are you going to do that ray diagram? Where is going to be the speed we want to have the first speed? Yes, it has 5 gears, 5 plus 1, we are going for the 5 gears. So still one more information we have not discussed. We have not taken consider the gear selection mechanism, right, because this is constant mesh, right. So in between you need to have gear selection mechanism, dog clutch, that is also will be part of that, and that should be common because you don't want to too many gear selection, dog clutch, you need to have a as minimum as possible. By doing that, again you are reducing the further the size and the mass of the gearbox, okay. So I will do from here, yeah, I will make it from right to left, assuming that the center distance is constant, right, the center distance between these two, right, the lathe shaft and output shaft is must be constant, the center distance, okay. This is the gear 1, this is gear 1, so that is the one. Then I will have a next higher speed, so 1, okay. Then I will have another speed, okay. Then one more higher speed. So supposed to be phase speed should be, I am taking, we are not considering space width at the moment, we are just for understanding purpose we are doing that, okay. Then we will have a fifth gear, yeah. So this happened, okay. So from here what I have done, I have taken this is my dog clutch arrangement for the dog aspect, okay. Usually the dog clutch arrangement will come at the this shaft, output shaft. Let me finish this one, okay. Yes. So you can see that this is my first speed, first gear, second gear, third gear, fourth gear and fifth gear. So we are not showing any reverse thing, only focusing about the first forward thing, okay. So and we have this is the output shift is clearly given. Where are we going to place the dog clutch? Right, we need to have a common one, okay. So usually we can have one common one between first and the second gear, that is a notation just showing, okay. When you have to give the enough space for between those sliding aspect. Then the next adjacent gear, it should be closer, The reason is the selection mechanism will come into here only, right? It won't be. So this is the one between first and second, and this will be third and fourth. Why I am emphasizing this also will fix your length of the shaft, right? The phase speed and the spacing between the gears are directly, right, fixing the length of the shaft. The length of shaft also need to be as small as possible, so that you will make it a gearbox as a compact. Okay, that's the one thing is there. So I have done this one, and finally you can have one more, right? Probably this is common, so probably this is common, right? So this, the fifth gear can be even more closer to the fourth gear, and you can have one gear selection mechanism, right? That would be in this position. Yeah. So this is the ray diagram. This is the way the ray diagram need to be arranged for the manual transmission. Much simpler, not as complex as a machine tool gearbox, because your speeds are 7, right? 5 here. In generally it will go 7 or 8 plus 1 forward thing, right? So as we discussed, can we have the numbers also? We can odd and even numbers, gear numbers. You can have 1, right? 1, 2, right? 1 and 2, right? 3, 4, 5, 6, 7, 8, 9, 10, so 10, 11 and 12. Okay, this is your 12. This would be 12. Okay, yeah. Another question is, which is the drive gear, which is a driven gear? What are the drive gears are, which are driven gears are? They systematically come in machine tool gearbox, right? It's always, we take it as a the odd ones are drive gears, evens are driven gears, but here is not the case. The transmission occurs from the clutch input to lay shaft. This is the one, right? Then from here the motion goes to your output shaft. Okay, it goes from here. It goes from here. Okay, so in that case your gears, gear 4, 6, 8, 10 and 12 are drive gears, right? Yeah, gear number 1 also drive. Okay, but when you say as a gearbox, we consider only this the first 5 gears. Okay, that's, yeah, that is coming from the engine. From the engine to we reduce straight away by certain ratio. Then from there, how we are distributing the speed, vehicle speed, right? In that case, would you consider the first 1, 2, or just the rest of the gears? Yes, absolutely, yes. Till then, because this would be the input, gear 2 would be the input for the your entire gearbox things. Okay. In fact, what happened to torque for the lathe shaft? Is it constant or variable? Torque. Yes, sir. Torque will be reduced. I mean, since you reduce the speed, the torque will be higher, but it will be constant torque. It will be constant torque on the lathe shaft, but in output shaft the torque will be variable torque. So that information you should be aware of that. Right. So when we do the model calculation, this information we will use and find out which way to solve the problem, to find out the required model for the given gearbox. Okay, and this is the ray diagram for the Maruti Dzire gearbox. Yeah. So I think this is a as a gear type. There is one more way you can as a represent as a line diagram. Okay, as a represent a line diagram. Let me ask one more question. This is a constant mesh. What happens if you have gearbox which is sliding mesh? What is the arrangement you see? What is the arrangement you see? The previously I have shown the picture also, right? I have shown the picture. So there will be only one gear will be mesh. Other gears will have a displace. Will be a part of the face width of the given gearbox. Okay. Obviously, the length of the shot will be higher. If you choose spur gear with the sliding mesh. So if you choose constant mesh, irrespective of the helical gear or circular mesh, okay, the shaft length will be reduced. Right. If you simply representing, just wanted to show as a line diagram, gearbox line diagram. Okay. Keeping this resistance constant. Yeah, that's it. So this should be okay. So you will have the mechanism here, this another one, then another one. Yeah, you can see that the first, second, third, fourth and fifth. Yeah. One information I would like to give, this is the input shaft from the clutch and this is the lathe shaft. Okay, and this is your output shaft to the further engine aspect. So here you can see here, right, this is coming from the engine, right, coming from engine, but we don't know what is the ratio. By default we reduce the half of the speed. Okay, then the gear ratio would be 2, right, by usually by default. Okay, it will be variable again. Gear reduction is 2 from the clutch input shaft to the counter gear in the lathe shaft. Yeah, but that information not given to us, right? It's not given to in the problem. If it's not given, usually we wanted to make it half of the speed, so reduce the, we have a gear ratio as a 2. Okay, so we have completed the ray diagram for the gearbox. Okay, the next stage or next step would be to find out the gear ratio. Find out the gear ratio between all the gears. Let me ask question, right, which is the smallest gear here? This is the one, right, this is the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is the smallest gear here, please tell me. 1, okay, that is already coming from the engine, so leave it that. Okay, if ignoring 1 and 2, what the rest of the gears, right, 3, Yeah, 3 or 12 also. Good observation. It could be 3 or 12. So my question is, in gears, would you prefer to have a drive gears design aspect, a driven gear design aspect? Yes? When I say drive gears and driven gears, from drive gear the force is transmitted, power is transmitted. In the driven gears, the power is taken. So which is create a more stress, the drive or driven? Drive. So you have to focus on the drive aspect, not the driven things, right? When you think about the gears calculation, your focus would be based on the drive. That is the one which is causing the stress to the other gear by contacting, by meshing. Okay. So if you look at, I would look at 4, 6, 8, 10 and 12. With that 12 will be the smallest gear, right? G12, smallest gear. Yeah, that's the thing. Okay. Now can we move on to the calculation? Yeah. So second part we are doing number of teeth calculations. Each gear in GB gearbox, okay, in the GB. Yeah. So you know, first I am talking about Z2, Z2 by Z1, right? That is given as a 2. We are taken as a assumed as a 2. Okay, that's fine. Now we will go for the first gear. What is the first gear ratio? Okay, what is the first gear ratio? Your IG1, the IG1 should be 3.545, 3.545, that we would expect from Z2 to Z1 and multiplying with your Z11 by Z12. So this is the difference you will see from the regular machine tool gearbox to automobile gearbox. This is the gear ratio, first gear ratio. Similarly, IG2, you have to refer your ray diagram, right? This should be there by default. Z2 by Z1 ratio always will be there. Then Z9 and Z10, that should give me 1.904. IG3, Z2 by Z1, okay. Then you have a Z7 by Z8, 1.233. Then IG4, that should be Z5, right? Z by 6, yeah, 0.911, and IG I will write at the bottom, IG5, what is the value? 0.7256, right? This one, these are the values, okay. These are the gear ratio correspondingly. So now we need to start to find out the number of teeth. Yeah. So number of teeth. So for first gear, here I will rewrite again, IG1, Z2 by Z1, okay, and Z11 by Z12 should be 3.545. Yeah, but we know that Z2 by Z1 equal to, I have taken as a 2, that is clearly. So which is the unknown to us? Both Z11, Z12 is unknown. So somewhere we have to start assuming minimum number of teeth. for gear number 12. Okay, gear number 12. So what we could do, always 12 should be greater than 17, because you know this, to avoid, is it undercut or interference? Undercut, right? To avoid undercut, the minimum number of should be greater than 17. Okay, we'll assume as a, let assume, because I already have done the calculation, so I'll 12, I'll assume it as a 80 number of speed. Okay, so now we need to sort it out. Z11 by 12. Okay, yeah. So already I know this 2. When you substitute, then I want to know the ratio between Z11 by Z12. So if I done that, it will be 1.7725, and assume that Z12 is the 80. When I do substitute that one, so the Z11 I would expect 31.905, approximately you can take it as a 32. Approximately you take it as a 32 Z11. Okay, and using center distance, remember, refer your the ray diagram, center distance, the number of teeth Z1 plus Z2 must be equivalent to Z11 plus Z12 based on the center distance. So one more information I would like to share here. Here in this problem, there is no constraint about the center distance, right? You can, whatever the center distance based on calculation, you can free to choose it. However, some place they have, you will get a problem, your center distance fixed. So for that you have to do the calculation, right? So I will give that kind of problem in the assignments. Okay. So now can we solve this problem, please? Yeah. So I know Z2 by everything. I need to bring it everything with respect to Z1. Okay. So a Z2 should be 2 times Z1, that is there, right? Z1 plus 2 times Z1 equal to Z11 plus 12, which already we know the values, which are, what is that, 32, right? 32 plus 18, which is coming 50. So tell me what is the value you are getting for a Z1? What is the value getting? How much? 17. Okay, right. Z1 is a 17. Then Z2 would be 34, right? 2 times, right? 34. So we got 17 and 34. Already we know other, which is other, Z11 equal to 32 and Z12 equal to 18. We got it. So this is one thing, we have finished it. Now we will move on to the gear ratio. Okay. Is it, my question is it solving? My question is, the number of teeth are matching. Look at, this is 32 plus 18 is a 50, right? It's a 50. Okay, whereas I got 17 and 34. Is it correct? No, it's not correct, right? So this is a 51 is coming. So 51 cannot be equal to 50. Then what is the step we are going to do that? Yeah. What is that we want to do? Yes. What is that we can do? I'm sorry? Yes, yes. That same best assumption. Okay. We got 18. T12 is 8, Z12 is at 18. That is clear. That is, yeah, that is assumed. That, yeah. Yeah, true. Okay. Now, I'm just wanted to find out another way also. In the gear ratio, what is the Z11 is coming? We got it, Z11. Let me go back here. One second. Yeah. So, this is what we got here, right? This is 32.9. Okay, we got 32 here. Then Z11 is 32 and 12, 18, that is coming here. Z is it exactly 17 Z1? That is the question. What is that value? 16.67. So, that is the problem, right? 16.67 is coming and we made it as a 17 thing. Yeah. So, that is not the correct, that is not the correct one. Okay. Instead of 18, what happened if we choose your T1 as a, okay, this Z1 17 and T2 34, okay, the 51, 18, okay. Let me ask question, another question. If this is 32, this is 32, okay, what happen if I make it as a round off, even though 31.9, if I make it as a 31 or 33, is it possible? Yes. Yeah. Any other answer? Yeah. Which one should I make 33? Z11 if I take 33, right? If I make Z11 as a 33, what happened? My Z12 remains same, right? Z12 remain same as a 18, right? Then what happened? My Z1? Yes, 17. Z1 will be 17. Z2 would be 34. So, now do the summation. This summation, right, it should give me 51. The similar summation if you do the 51. So, that satisfies, right. So, if you are assuming, right, Z11 as a 33, not assuming, rounding off to 33, you would expect a Z12 be as a 18 and Z1 17 and Z2 correspondingly 34. So, by center distance aspect, we are matching the number of teeth, right, number of meshing teeth we have matched. Now, we will move on to gear ratio 2, right, gear ratio 2, your Ig2 Z2 by Z1, right, and Z9 by, same way we have to start, Z10 1.904, yeah, 1.904, but already we know Z2 and 1 are already known to us, their values are known to us, okay. So, so the 17 and 54 that are already known to us. So, we need to focus only about the 9, Z9 and Z10, yeah, right. So, same way your Z2, let me rewrite Z1 plus Z2 equal to Z9 plus Z10. You have to use the center distance equation by center distance method, right. So, if you solve it, I am not going to detail, I will straight away going to give the answer. So, Z9 should be 26 and Z10 25, right, 25 and 26, it should be coming as a 51, okay, it should be satisfying 51, correct. And gear ratio 3, Okay. For gear ratio, third gear ratio 3, Ig3, the Ig3 equal to Z2 by Z1 into 7 by 8, 1.233. So, already is known to you, only you have to find out Z7 and Z8 as usual using a center distance method. Okay. As usual using a center distance method, your T7 plus Z8 Z7 plus Z8 must be 51, right? And you know the ratio also, Z7 by Z8 ratio also 1, you know that. By solving it, you would expect your Z7 teeth 19 and Z8 is a 32. So, please work it on, you will get this answer. So, even if it's adding this one, that give me number of teeth as a 51, total number of teeth using center distance method. Gear ratio for fourth gear 4, your Ig4 equal to Z2 by Z1, right, into Z5 by Z6 equal to 0.911. Yeah. So, Z5 alone we take it as the ratio 0.4555, right. So, we know the summation Z5 plus Z6 should give me 51. Yeah. So, when you substitute this A and B as you did in the previous things, I would expect Z6 should be 35 and Z5 is 16. So, this is the number of teeth you would expect for gear ratio number 4. Okay, gear ratio number 4. Yeah, this is done. Now, we will move on to gear ratio number 4. Ah, 5. Thank you. Gear ratio 5. Your Ig5 Z2 by Z1, okay, Z3 by Z4, that should be 0.7256. Using same as your standard distance method, try to find out the number of teeth 0.3628. Finally, you would expect Z3 equal to 14 and Z4 equal to 37. So, that is the summation 51 is comes. So, just let me write down individually 1, okay, then matching 2, 3, 4, 5 and 6. So, 17, 34, 14, 37, 16, 35, right. Now, Z7 19, corresponding Z8 32, Z9 equal to 26, Z10 equal to 25 and Z11 33 and Z12 equal to 18. Yeah, I think this I think we got all the values. Okay. So, whatever you see, these are the drive gears number of teeth. These are again 2 except 2, I think, yeah, 4, 6, 8, 10, 12 are drive gears. whereas rest of gear driven gears. Okay, you might ask question, sir, we have choose number of teeth 17 and above, but you got number of teeth on the driven gears 14, 16. Is it good? Does it causing a problem, design problem? Right. So just think about that. So we'll continue next lecture for the model calculation aspect. Okay. Thank you.